Hello folks, for this video I'll be talking about a study we have done which is about applications of the artificial intelligence techniques on the Titanic disaster, Titanic accident, which happened 101 years ago. And we have done this study with my friends Ahmet, Chul, William, and Erhan, and me, Ali. So the reason why we have done this study is, even though there's been a lot of time after the Titanic disaster, it has still been captivating a lot of interest from the people all around the world. It was not popularized only by the movie, which Leonardo DiCaprio acts, but also it is being popularized by the actual scientific expeditions, which is undertaken to reach more conclusive answers to the questions surrounding the end of the Titanic. And what we thought about that is that with the advent of the computer science and computational power, the area of big data, data mining, artificial intelligence, pattern recognition techniques, maybe they might allow us to draw insights into some of the controversial surrounding the Titanic's demise in terms of who survived, who did not, and why. What was the main characteristics of those who survived? What was the main reasons underlying that situations? Things like that. So overarching goal of the project was basically to predict if a person will die or live at the end after the accident. So datasets, we've obtained the datasets from Kagel's own websites. There were basically two datasets. One of them is training and the other one is the test dataset. And there were 11 variables. And the question came to our mind, which is it a survival study or not? We have been seeing survival study term a lot in the biostatistics part. But here in this study, since there is no time-related variable which might affect the dependent variable, it is not a survival study. In a usual survival studies, there is a time-related variable which directly affects the dependent variable, which makes that specific study a survival study. But in this case, we don't have that. Pre-processing of the data, we have cleaned the variables which does not have any effect on the dependent variable. For example, the name of the people will not be affecting the dependent variable. So we've cleaned that data, and we've categorized the data in terms of if it is the ordinal variable or if it is the categorical, if it is the continuous, which has a great impact of determining the dependent variable. So the machine learning techniques that what we have used is the decision trees, neural networks, random forest, and support vector machines, so that we can compare them to each other and we can have the important variables tool, which we will drive the insights of the study. And then there was one more question: how should we overcome the overfitting issue? What we have thought about that is that instead of splitting the data into two as training and test data set, we have chosen to use k-fold cross validation technique, which we have used 10 instead of k, and using this technique is allowing us to decrease the level of overfitting issue as much as it can. So before, we had some missing variables in dataset. Before doing the imputation, we have applied those techniques, and basically the decision tree, which is the CRT model, was the best doing model with the error rate of 18%. And then before that, as I said, CRT was doing 18.79, and then SPM was doing 20.39. And then we've taken a snapshot from the decision tree graph. As you see from the decision tree graph, the first node is the sex, which discriminates the people into two, and then the cabin number, And then we have got some cross-validation tables, which we will explain in the presentations. But what I want to emphasize is that um we have the selected predictors based on their importance. Even though cabin is the most important variable and sex is the second, in the decision tree model it is the vice versa, because in the decision tree model it doesn't mean that the first node is the most important variable, but it is the most discriminative variable maybe. And then at the end of the study we have found that the cabin number has a great importance of determining if that person is going to live or die. So since it has a lot of missing value in that column, in that variable, we have tried to make an imputation, and there were some alternatives. One of them is single imputation techniques and multiple imputation techniques. The highest, and what we have thought about that, whatever the highest correlation with that variable, we have kind of done a heuristic study to make an imputation on that case. And then after imputation, we run those machine learning techniques again, which I had already mentioned: SVM, decision trees, random forest, and neural networks. Because all of them has some pros and cons, so they will allow us to compare and contrast their capabilities based on a specific data set. So after making the imputation, SVM was the best running model, which with the rate of with the error rate of 12%. And as we might remember from the class, SVM is able to take into collinearity into account. And then the cabin number and sex are the most important variables based on our study. As you see, SVM after making the imputation, SVM is doing the best, and then neural network is the second best model in our study. And then again we have some confusion metric studies, which we will mention about the details during the presentation. And again we have the variables based on their ranking of the importance. That's basically what we are doing on our study, and we'll go into details in our presentation. Thank you very much.